The next session's esteemed chair, esteemed moderator, and speakers are as follows. Mr. U.P. Singh, who's chairing the session, former Secretary, Ministry of Textiles and Jal Shakti. Ms. Noah Amsalem, she's moderating this session. She's Water Attaché, Embassy of Israel. Mr. Devendra Singh Fonia, Chief Marketing Officer, BP Clean. Ms. Laura Serstesik, Project Manager, Implementation Support to the India-EU Water Partnership, GIZ India. Dr. S.K. Sharma, former member, CGWB, Principal Advisor, IWF, and Professor Dr. A.K. Keshari, Department of Civil Engineering, IIT Delhi. A quick introduction to all of our esteemed panelists and the chair and the moderator of this session. Mr. U.P. Singh is a 1985 batch IAS officer with a career spanning 37 years. He's an expert on water sector, having spent more than 6 years in the water sector. He was also the first Director General of National Mission for Clean Ganga before taking over as Secretary, Ministry of Jal Shakti. We have with us Ms. Noah Amsalem. She serves as the Water Attaché at the Embassy of Israel in New Delhi and brings extensive expertise in water management, having worked closely with governments, industries, and academia to promote innovative water solutions. So welcome back to both of you. We warmly welcome Ms. Laura Serstesik. She is the GIZ's Project Director of the Support to Ganga Rejuvenation and of the India-EU Water Partnership Action, which is also co-financed by the German Ministry of Economic Cooperation and the European Union to enhance cooperation on water issues between India and Europe. She's been working for more than 20 years in water supply and sanitation and integrated water management in Asia, Africa, and Europe. A very warm welcome to you. We warmly welcome Dr. S.K. Sharma, former member, CGWB and Advisor, Ministry of Water Resources, Government of India, Principal Advisor, India Water Foundation, a renowned water expert and former government advisor with extensive experience in water resource management. A very warm welcome to you, sir. We extend a warm welcome to Professor A.K. Keshari. He's Professor Water Resources Engineering, IIT Delhi. He holds a PhD from IIT Kanpur and has expertise in hydrological and environmental modeling. Sustainable development, he also has experience in FEM, waste management, sewerage systems, policy analysis, and risk assessment. Mr. Devendra Singh Fonia is Chief Marketing Officer, BioPetroClean. So here's extending a warm welcome to all of you once again. I hand it over to the esteemed chair and the moderator to take it over from here.
Very good afternoon to all of you. I was just wondering whether there are more people on the dais or more people off the dais. Then I made a head calculation and I find still we are in the minority, you are still in the majority. I hope there is no more session after this, otherwise there would be more speakers than the people out there. I was here in the forenoon session also, and Noah was also with me in the morning. And in the morning, I was a little afraid whether I'll get time to have my say or not, so I spoke in the beginning. This time allotted to us was 1 hour 15 minutes. We are starting 25 minutes late, so I don't know whether that 1 hour 15 minutes, which was time was allotted for this session, is still valid. But what I would do this time is that I would not speak in the beginning. Hopefully, I'll get some time in the end, so that I will also have my say. Okay, you have my questions to me. Okay. So what okay, so fine. What I will do is I'll give it to you basically. And so one doesn't go to speak, maybe one speaks to a specific questions. So, but we should keep in mind that altogether we have maybe about an hour or so, maybe 10 minutes could be kept, because I find very interesting. If somebody was asking about the urban flooding, I have also been talking about urban flooding. और मुझे ऐसा लगा कि जो चीज़ असली चीज़ होती है उसे किसी ने नहीं बताया. Pardon me, मतलब I'm not saying कि असली चीज़ मैं बताने जा रहा हूँ. अब I'll just take 2 minutes before I hand it over to you. सब सही है. It's also a fact that because of the climate change, the rainfall pattern is becoming very weird. The overall rainfall continues to be by and large same. But earlier what used to have, the number of rainy days used to be very high. These days, number of rainy days has come, the intensity of rains. Earlier that 400 millimeter rainfall would be spread over 30 days, 20 days. Now 200 or 300 or 400 millimeter rainfall takes place in 2 hours or 3 hours. And our infrastructure, urban infrastructure, were never constructed taking into account that 200 or 300 or 400 millimeter rainfall in 2 hours or 3 hours. The other things also they said, right, there are encroachments, rampant encroachment. But one thing which nobody talks of, I always say, कि भाई जो पहले पानी बरसता था वो पानी जाता कहाँ था? पानी जाने का दो ही रास्ता होता है. Either पानी जमीन के नीचे जाएगा. Everybody knows ना, ground water aquifers we talk of. सबसे बड़ा रिजर्वायर पानी का कौन सा है? All the reservoirs put together in India do not store as much water as water is stored beneath us in the groundwater aquifers. तो पानी तो groundwater aquifer में जाता था. अब हमने क्या किया कि in India and many other countries also, the development means concretization. We concretize everywhere blindly because development means either construction or concretization. तो पानी अब नीचे नहीं जा पाता है. पानी जो पानी के नीचे जाता था. दूसरा क्या था, वो पानी जो है वो रास्ते से किसी न किसी वाटर बॉडीज में जाता था. Delhi used to have more than 1,000 big water bodies. Bangalore used to be called a city of lakes. तो दोनों चीज खत्म हो गया. पानी जाने का जो रास्ता होता था, the natural drainages which used to carry the water to the water bodies, वो खत्म कर दिया. हमने जहाँ roads बनाए, हमने जहाँ पे railway बनाए, हमने जो भी बनाया, we never recognize the right of the water. उनके हमने right of way को सोचा ही नहीं. That is one. And thirdly, जो water bodies थे, water bodies गायब हो गए. तो पानी जाएगा कहाँ? पानी न तो नीचे जाएगा, न तो पानी रास्ते से water bodies में जाएगा. तो पानी आपके घर में ही तो घुसेगा. And this is what's happening. But anyway, that's besides, since I was sitting there and listening. तो हमें कहा कि भाई हमें ये सोचना चाहिए कि हमको लगता है कि भाई यहाँ पे बहुत कीचड़ हो रहा है. भाई कीचड़ बड़े काम की चीज़ है. मैं तो ये कहता हूँ. मैं कहता हूँ, don't concretize everywhere. There are a deconcretization movement in many of the Western countries today. But having said that, that came because of the last discussion. So I hand it over to Noah. I think that's the easier to pronounce. Is that fine, Noah? Okay. So I hand it over to her. She said that she has certain questions. I am very afraid of questions. What happens is that I speak on whatever I know of. All of a sudden जैसे होता है ना कि syllabus से बाहर का कोई question पूछ दिया. और वैसे भी क्या होता है ना कि all these terminology I'm very afraid of. अब इसमें लिखा हुआ है जैसे water transversality. अब मुझे तो प्रोनाउंस करना भी नहीं आता यार कि ट्रांसवर्सलिटी क्या होता है. मैंने डिक्शनरी में इसकी मीनिंग भी खोजने की कोशिश की तो मुझे ज़्यादा समझ में नहीं आया. I'm a generalist person. I have spent 37.5 years in IAS dealing with the general subjects. Even though I did study engineering from IIT, but I have forgotten that. So don't ask me the questions which will have these kind of transversality kind of questions. But anyway, choice is mine as far as answering is concerned. Okay, thank you very much. And over to you.
Okay, so good afternoon. Our session, our panel is about water use efficiency in industrial sector amidst a climate emergency. As we all know, water use efficiency is more important than ever as climate change makes water shortage worse. Managing water wisely is essential to support growing population, farming, and nature with less available water. We have to remember that when we speak about water use, we also speak about reuse, which is a great factor of reducing the stress on water sources and saving fresh water for other needs. Our discussion today will focus on water use efficiency in industrial sector. I want to give just one example from Israel. Since 90% of the wastewater is being treated and used for agriculture, and because all sewage is going to centralized STPs, so every factory has to treat their own sewage in-house to a domestic level in order to allow to add their sewage to the network. So this is one example of how industry can contribute to the effort. And now I will stop talking and will ask questions. And I will start with you, Ms. Laura, project manager in GIZ, sorry. So please, how is GIZ supporting the adoption of water efficient technologies in Indian industries? And could you provide some examples of successful projects or technologies that have shown promising results?
Thank you. Good afternoon, everyone, esteemed panelists. Good afternoon. A special greeting also to Mr. Singh. I have been associated with the GIZ and the project Support to Ganga Rejuvenation since the end of 2018. And in that occasion, we had to do with Mr. Singh as a secretary, and we had a quite successful journey together. So it's good to see you again. So with the project and the co-financing of the European Union, we have supported the Ministry of Jal Shakti to develop what is called the Framework for Safe Reuse of Treated Water. And that has been officially launched at the All Secretaries meeting last year in January in Bhopal, 2023. And that is a central government framework for the safe reuse of treated wastewater coming from municipal uses, for different uses. That is, the intention is to give a framework under which so state policies can be harmonized. So following this framework, several state policies are being developed. We are also supporting development of policies in Uttarakhand and Uttar Pradesh for the safe reuse of treated water. But today I will tell you about another study that we did, really interesting, on a very interesting case in Panipat in Haryana nearby. So in Panipat, falls in the Ganges Basin. This is why we have been working on that with the National Mission for Clean Ganga. And Panipat is an interesting city. It has got a very large industrial component, so an industrial cluster with, let me see here, 450 textile industries in one cluster that is called Section 29. And Panipat city is crossed by the national highway. So we have one left and one right side, let's say, of Panipat city. On one side of the city there is the railway, and on the other side there is a water canal that is bringing water for drinking purposes and other purposes all the way to Delhi. So this large industrial sector, now you know the textile industries have quite specific needs in terms of water, because they use water for the nozzles when they are printing textiles, and the nozzles are very fine. So the quality of water has to be very good, very high, and TDS, so suspended solids, has to be very low level. So where does this industry of this cluster of textile industries get the water from? Part of it is from the groundwater, but Haryana and Panipat is very scarce in terms of groundwater, is extremely overexploited, and even the little water that is there is very high in suspended solids. So that is part of the water, and there is part of water supplied by the industrial corporation, used by the textile industry, treated in a CETP near the cluster, and then released straight into the Yamuna. And large part of this, let's say, almost drinking water, quality water, aside from the groundwater, comes from the canal. I mentioned earlier this canal that is running on the other side of the city, through a pipeline which is about 10 kilometers long. Finally, why is NMCG involved in this whole situation is that the Yamuna, there where the water is being discharged from the CETP into the river, is still quite a hotspot in terms of pollution. We all know that Yamuna near Delhi has got some problems of pollution, and that spot is particularly difficult. So we carried out a study to see whether it's possible to reuse treated water from STPs, so from municipal use, from that side of the city that lays on, let's say, nearby the textile cluster, whether it is possible and whether it is economically feasible to use that treated water for the textile cluster. And the result was that yes, it is possible. The STPs are very, very close to the industrial cluster. Yes, it's possible also in terms of volumes. The industrial cluster, I think, needs about, 40 MLD, and the STP would provide 60, so it would cover the demand. Also, in terms of logistics, the STPs are very close to the industrial cluster, so it would be possible to lay a pipeline of about 2 kilometers from the STP to the reservoir, the tanks that then supply water to the textile cluster. So that would skip, or let's say would do without the 10 kilometers pipeline plus all the pumping costs that come from the canal, the water that comes from the canal. And finally, the water quality that comes out from this STP is very good. It's so good that the industries in the textile cluster already on their own, they had done some tests and some measurements on the quality of this wastewater to see whether it would be feasible, and they are very interested in this. So we have done a study taking into consideration all this, running some simulations to see also in terms of cost and revenue. And a viable business model has been identified where there would be the installment of a treatment plant, tertiary treatment, that would treat the water from the STP at a level that is acceptable for the textile industry, provided that capital costs are provided by the state and by the Industrial Development Cooperation. Operation and maintenance costs would be covered, and it would be possible to do a build, operation, operate and transfer kind of business model for this sewage treatment. And basically, operational costs would be covered through water fees to the textile industry. So this is a very interesting model that we have supported an MCG to develop, that shows that these business models are possible. Obviously, this is possible. Why? Because groundwater is anyway scarce. There is no surface water that is available there, and the infrastructure is there. NMCG has presented this to the Central Monitoring Committee, which is a state committee, as you know, that controls basically the whole expenditure and efficiency of the National Mission for Clean Ganga. And the Central Monitoring Committee has proposed and directed the Haryana government to actually implement this kind of solution that would be economically feasible and would both save the water resources there in these times also of climate change, and hopefully also contribute to decreasing the pollution that goes into the Yamuna in that spot. What about technology, you were asking me? So reverse osmosis obviously would be the best choice, but it's very expensive. But the model showed that ultrafiltration would also do. So that would give water quality good enough for the textile and also satisfy the economic viability of the system. So it's quite an interesting case study. Thank you.
Thank you, Ms. Laura. I truly believe that using the treated wastewater for industry is the next step in Indian water sector. It's a way to break the barrier of using the treated water. Industry is a strong sector that can also pay for the infrastructure. So hopefully it will lead to further use also for agriculture. So thank you, very interesting. So now to you, Dr. Arvind Kumar, President of India Water Foundation. Thank you for having us here. He's not? I thought he's here, sorry, sorry. So, Dr. A.K., so this is you. A.K. Keshari. no, Professor Doctor, A.K. Keshri. Department of Civil Engineering, IIT Delhi. Sorry. Yes, I know. You are next for the. Yes, sure. Please be seated. Ah, okay. So, Dr. S.K. Sharma, please.
Good afternoon, everybody. The topic chosen is water use efficiency in industrial sector amidst climate emergency. The growth and the pace of rapid industrialization is putting impact on water resources, leading to enhancement in water demands. Water-intensive industries in the country include thermal power plants, pulp and paper industries, textile industries, iron and steel industries. The objectives of presentation include highlighting the importance of water use efficiency in the industries, exploring Indian and global perspective, showcases of successful implementations, and providing actionable recommendations for stakeholders. Water use efficiency, this concept, from where did it come? Was introduced 100 years ago by Briggs and Shantz in the United States in 1913, showing a relationship between plant productivity and water use. Water use efficiency is a measure of the amount of biomass produced per unit of water used by a plant. Water used by industry. Industries are committed to water stewardship approach, a method to benchmark and create standards and certification processes in sustainable water use. Implementing policies for improving and achieving water productivity gains are primary business both of the government and private sectors. Industrial use of water. The manufacturing industry, they use in the creation of processing, washing, cooling, transporting of products. The textile industry uses water for washing, spinning, bleaching, dyeing, printing. According to the US Geological Survey, when I visited Atlanta a few years ago, they told me that industrial water use is used for fabricating, processing, washing, diluting, cooling, or transporting products. 4 industrial uses of water include ultra water use in semiconductor manufacturing, cooling water, water use in oil and gas markets, water use in pulp and paper mills. Significance of water use in industrial sector. It is significant for addressing water crisis and climate change. Industry's water sector has low water use efficiency and is heavily dependent on water supply. The assessment of the water and its quality is what needed. India is water stressed and is expected to move into category of water scarce nations. Extreme weather events are making water more scarce, non-predictable, and more polluted. Impact through the water cycle threatens sustainable development, biodiversity, and people's access to water. A concept is now steadily increasing that rectifying measures of climate change impacts would need to be taken by industries to augment fresh water through rainwater harvesting and water treatment and reuse. Now, the challenges to water efficiency include high water intensity, technological gaps, policy and regulation measures, and climate impacts. Can be taken as having been read. Climate challenges to industries. Energy supply. It can affect safety of facility and supply of energy. Water scarcity can threaten industries that use a lot of water, such as power generation, textile, and agriculture. Extreme weather events like cyclone, floods, and heat waves can damage facilities, disrupt supply chains, and halt production. Fossil fuel generation. Regulations on fossil fuel can threaten the oil, gas, and coal industries. Increased production costs from carbon taxes can make industries less competitive. Climate change can create supply chain pressure. Now, water risks associated with industries to include inadequacy of water, poor water quality. Smaller and drier area industries face problem of high water cost, climate and environmental changes, regulatory policies related to functioning of industries. These are some of the risks associated with industries. Now, needed rectification measures by industries to augment fresh water. 1, rainwater harvesting. 2, water treatment and reuse using treated wastewater for gardening, ash handling, washing of ores. These are some of the preferred choices for industries. Water auditing for understanding water use pattern in operation as well as in planning of water saving measures, and adopting water conservation measures through water modeling. Now, strategies for water use efficiencies. They are technological innovations, policy frameworks, and behavioral changes. Now, pathways to conserve water in industry applications. This is very important. Conservation, recycling, and reuse must be practiced by all industries. Minimizing unnecessary water use in exterior landscaping. Prioritize maintenance, cleaning, and repair of water-consuming equipments. Upgrade existing water-using fixtures for industrial use. Perform audit of water use. Protect system against water loss. Conserve water in facility equipments. Install headwater meters in boilers for monitoring of incoming water. Replace outdated equipments with energy-efficient alternatives, and perform rainwater harvesting practices. Now, pathways to improve water use in industry. Modify equipments. Install trigger operations on hoses, nozzles, shower fixtures to regulate flow of water. Adding timers and paddles to ensuring that water is used sparingly and effectively. Installing sub-metering systems, minimizing water use for cleaning, installing water-saving toilets, adjusting water flow to the maximum required, and then reducing runoff and percolation losses. Reporting to use of innovative techniques for water use efficiencies, such as resorting to such techniques, advanced sensors, then artificial intelligence for water quality monitoring. Example, nanotechnology and desalination. Now, benefits of water use efficiency: economic benefits, cost saving, reducing energy use, environmental benefits, conservation of fresh water, reduced wastage of discharge, then social benefits, improved water scarcity for communities, climate adaptation, increased resilience to climate-induced water stress. Now, case studies, as you see, Netherlands, and for their industrial water recycling, for their sector, petrochemical industry, the initiative used by them is adoption of zero liquid discharge system. And the impact caused a 60% reduction in freshwater withdrawal, significant cost savings, and resource conservation. An example of another study in Singapore, Water Energy Nexus, the sector is electronics and manufacturing industry. The technology uses the integration of advanced membrane filtration and wastewater treatment plants. Similarly, one example of the Indian success story, Tata Steel Jamshedpur, and the initiative is a comprehensive water management program, measures is rainwater harvesting, process optimization to reduce water footprint. The result is reduced water intensity by 25% and alignment with sustainability goals. Recommendations for the way forward. For industries, they should invest in efficient technologies, monitor and report usage. For policymakers, strengthen water efficiency standards, encourage green financing for water efficient projects. For researchers, they should keep on exploring new methods for low cost efficiency. For stakeholders, collaborative efforts across stakeholders can drive transformative impacts. Learning from global success stories can help country lead sustainable industrial water management. Now, finally, industries facing scarcity of water amidst climate change need to implement water conservation plans, that is rainwater harvesting and recharging, and boost water use efficiency. Water conservation can be viewed as a part of policy to reduce carbon dioxide emission and improving water use efficiency. Thank you, ladies and gentlemen.
Thank you. Can I ask you a question also? Please. You want? Okay. So, as a former member of Central Groundwater Board, I'm guessing you've seen the evolution of policies related to water use. So, how do you view the current regulatory environment around water use in industries?
I don't understand your question.
How do you see the current, the current regulatory environment around water use in industry? Current regulatory?
The groundwater regulation is being done by Central Groundwater Authority under the Ministry of Jal Shakti. I was the first member of in charge of the Central Groundwater Quality Authority in 1986. The powers given by the Supreme Court to me asked me by calling, why are you not notifying the area which has groundwater overexploited? So I thought the charity must begin at home in the neighborhood of the Ministry of Jal Shakti. Why not to notify the areas which are groundwater overexploited in the NCT, Delhi first. So all the NCT regions were notified by me, which were groundwater overexploited, where the groundwater extraction was much more beyond the annual availability of groundwater, more than 100%. Even today, many areas are having 200%. So they have been notified, the notification guidelines have been prepared, and the users who want to put a tube well, they need to put an application to the authority, and they are as per those guidelines, and they want to extract this much water, and this much they must input through the rainwater harvesting as also. So these are the guidelines, they are available on this thing. That there is nothing no problem in these things. And this is being achieved. And the powers of the authority have been delegated to the district administration, that they should keep a track that nobody should illegally construct a tube well. But as I see today, the DC in charge, DM in charge, he is not reporting to the chairman of the authority. Now the chairman is asking him to report after every month how many illegal cases he has caught and what is the thing. And this is what is happening. If I happened to be there, I would have done all these things. This is not happening. So this is not, to my mind, very wisely being attended to. Thank you.
Thank you very much. Okay, so now Professor A.K. Keshari, Department of Civil Engineering, IIT Delhi. I have a question. Do you have a presentation? Both. Okay.
You can start with the question or
Okay. So from a technical perspective, what role can the Educational and Research Institute play in advancing water efficient practices in industries? And how can collaboration between academia and industries help in finding sustainable solutions?
You see, being an academic institute, primarily our role comes in the technology. So either we develop technology or we provide technology to the industry, for effective use at the field level. Currently, I'll just give you some of the examples recently what we have been doing, and we have got it implemented also. The first, which is a very significant in India, that we collaborated with the CII, which is the Confederation of Indian Industries, and also with the Niti Aayog. We have developed the blue rating system on a parallel lines of the energy rating. So that what it helps, basically, if you look back, the work of the Netherlands, which came with the concept of the water footprint, but that was more on the business, truly speaking. Okay.
we translate it into in terms of the, the effective utilization for effective management of the water within the industry. So what we did, that we have brought all the industries to go for the computation of a specific water use. So what is going to be the specific water use for each of the product, whatever they are generating. So let us say if they are saying textile, how much water is utilized in the production of 1 ton of the, the textile, or 1 ton of the steel, or 1 unit of the automobile.
Are you talking about quality or only quantity?
We are talking about both. First of all, we say that the specific water consumption should be based on the fresh water resources. Then we also say it should be in totality, bringing the other aspect, like how much you are generating the wastewater, then how much you are bringing into the recycle. So what percentage goes into the recycle, how much you are able to, recover from that, and then how much then you are sending to the disposal. Disposal, primarily nowadays in India, we have ZLD compliance for most of the industries. So they don't have to dispose to any water body. So for that we brought the 2 concepts. One is the within the fence, and another we call outside of the fence. So within the fence means they have to do certain activities within the premises of the industry, that how they are managing, and they are not disposing the water outside of their premises. When we say the outside of the fence, that means irrespective of what business they are doing, they have to do under some activity for the watershed, under the CSR concept, that what they are doing for the livelihood of the people, or the rejuvenation of the pond, or the rejuvenation of that hydrologic regime of that watershed. So that we count under the outside of the fence. So these 2 practices we have got it implemented within the industry. And in terms of the blue rating, so the blue rating has been designed that what they are doing for the benefit of the watershed within the industry and outside of the industry. So we have certain parameters, so around 10, 12 parameters we have outlined. So and then we have made a composite rate, and then they have to qualify for that, whether they are silver, platinum, or the starting level. And the CIA has also started giving award to them on the yearly basis, that how they are performing. So we have, being an academic institute, we have contributed in the development of that blue rating and the specific water consumption, and how with the time they are trying to reduce the fresh water consumption and trying to look for the alternate resources. Like some of the industry are entirely now utilizing the wastewater, or you can say the processed or treated wastewater for their whole industrial operations. And one of the classic example you can think of the Tamil Nadu newsprint. Then the Tata group, which are running in the Jamshedpur, that supplying the whole drinking water supply through the treated wastewater. So those are something very successful thing. And there are many industries which have brought down the specific water consumption on a yearly to yearly basis. So that is one significant, we'll say, the contribution we have done, and then we are trying to get it done for the all industry. The dimension what I would like to say, that we are also advocating embracing the new technology, like especially making use of the satellite imageries, then the multispectral, particularly multispectral satellite imageries, and then with the mathematical modeling, and then the machine learning techniques, like as it is being posed for the urban flooding or the riverine flooding. So we have now a good tool to quantify how much impervious surface we have in a particular area. And that helps us to compute how much runoff will be generated. So what should be the adequacy of the stormwater drainage, that we can quickly compute now for any water, for any specific city. So like, I'll show you some of the slide which we have done for Delhi itself. Then we'll also, we are bringing in, like suppose some activity comes in. Suppose in a city, if somebody wants to make this site as a sanitary landfill site, whether it is a good site for that or not. So is it going to give a contamination to groundwater or not? So we are trying to, you can say, see the evolution of the plume, which can result without the occurrence of the event. But generally like flood, the flood event takes place, then we see the repercussion. But here, through the mathematical model, we are trying to simulate those events which can happen if this decision is taken. So those kind of the tools we have developed, and we are making use of those in the decision making. We're helping the government, and I would like to show some of the slides related to this, if you permit. I'll show you only those slides, not full presentation. Yeah. Thank you. Can you go with the presentation? I'll just say where to stop. Yeah, go next. Just go to the figures. Yes. Yeah. Next. No, not this. Next. Leave this. Next, please. Next. Leave this. These are. Leave this also. Leave this also. Yeah, like here, I was talking about the river Yamuna. So you can see here, this is the origin of the river, Yamunotri, and that is what the state you see in Delhi. Go to the next. Yeah, so we have tried to monitor the water quality. You can see in the whole Delhi stretch, starting from zero, that is the Wazirabad, the plant there, and then the kilometer that is goes to the Okla Brass side. So we try to monitor the odd water quality parameter. We estimated how much wastewater the system can take. And then we try to develop an algorithm that what should be the re-aeration capacity of a degraded river. Currently we have the re-aeration capacity only of the real rivers, or you can say which are not polluted. But the Yamuna is totally different because it has a lot of pollution, organic and inorganic both. So we try to develop an algorithm what could be the assimilation capacity of the river, so that beyond this wastewater, it can die, or its health will go down. So we can take the corrective measures. Go to the next. So like that, we had monitored different parameters at different stations like Wazirabad, ITO, Nizamuddin, and Okla, and we tried to develop this algorithm. Go to the next. Because we know that in most of the cities, we don't have the adequate, the STP plants which can treat effectively. I mean, most of this thing you can see, it is less than 50%. Yeah, next. So this is what I was talking about within the industry, that we are working on the process interventions or the technology intervention. In technology interventions, I'll give you one example, that in thermal power plants, we have advocated that you should move from the wet quenching to the dry quenching, so that you are reducing the fresh water consumption. We have also introduced that how you can transport the slurry to the fly ash ponds, and how you can make those fly ash ponds the leachate proof, so that it doesn't contaminate to the groundwater. Yeah, next one. Go next. So these are something which I was showing you, the satellite and drone imagery. Yeah, go to the next. So we also estimate how much water is required for the crops in the agricultural field, and then we can compute the water use efficiency, because in India, most of the water use efficiency is very low in the agriculture sector as compared to the other domestic or industrial sector. So there we also wanted to put some kind of intervention, how effectively these satellite images can give us the better estimate of the water requirement by the crops, so that they can do the irrigation scheduling to reduce the water consumption. Next. Yeah, you can go on putting next. So these are the satellite imagery. We had computed from those satellite imagery for the sensible heat flux, latent heat flux, and then the actual evapotranspiration taking from the plants. Next one. So this is something we try to develop the algorithm for computing the precise estimate of the imperviousness or concretization in the urban cities by developing a machine learning algorithm, by making use of a spectral unmixing algorithm, and we try to validate that whether this performs well or not. We have also got it published in the International Journal of Remote Sensing. So this was something like the spectral unmixing based on the CNN algorithm. Yeah, next one. So we try to develop for the whole Delhi, so you can see here, and then we compared with the Google Earth engine and the actual site visits to see the accuracy of the model. So like we did for vegetation, impervious surfaces, and soil, so that it can help us in the urban planning and developing what kind of the urban flooding systems we require, or what kind of the storm drainage system we require. Next one. So these are the different. So we also try to see the efficacy of the two satellite images like Landsat ETM or Astra data in give and different kind of the machine learning algorithm to accurately, precisely get the estimate in the urban city where it is more heterogeneous and more the infrastructure is existing. Next one. Few more slides. This you can see the temporal dynamics of Delhi, how the impervious surfaces is changing from 1992 to 2017. The next one. This is, we try to also work on the, since in India we have very wide geography, so wide you can say the climate and you can say the watershed characteristics. Many areas like in Himachal and other kind of thing, we have the snow and glacier contribution. So we try to estimate for the bias that how we can estimate the land surface temperature we can retrieve from those satellite data. So we estimated for the Bias River Basin and we computed to know whether the glaciers are shrinking or not, what is going to be the contribution from the melt or the snow melt or the glacier melt to the runoff which comes to the river, and whether that is going to give the flood or not, or how it is going to put the stress on the water. Yeah, next one. So this you can see for the delineation of the glaciers in the Himachal for the Parvati Basin through different techniques. Yeah, next one. So we mapped from the MODI satellite images how the glaciers is changing. So white patches are giving basically the changing the snow cover. Yeah, next one. This you can see the specific the mass loss or the glacier mass loss from 1998 to 2016. We have computed for the Parvati Glacier in Himachal, and that is going to impact the hydropower generation in that area. Yeah, next one. Just two more slides. This we try to see the implications of the climate change on the Koyna water basin in Maharashtra. So how the land use changing from 1996 to 2016, and then how this change in land use is impacting the runoff in the river and water availability in the Maharashtra region. Because you know in Maharashtra we face a lot of drought in many parts. Yeah, next one. So this is this similar study for the climate change implications on the water availability in the Maharashtra. Next one. This is something, again, another study, how to see implications of any kind of the landfill, whether the leachate is going to give any kind of the contamination in the area or not, or whether we should go for that kind of the landfill in a particular site or not. So it is a kind of, you can see environmental impact assessment. So you can see here in Delhi, those are the pits which were thought of making a landfill site. Can you go next? So like you can see how it looks like. This is a very quartzite rock exposed to the surface, very impervious, but very weathered. It allows the recharging because of the fractures, but it will allow the contamination if there is a landfill, because the leachate will get to the soil and then that will migrate to the groundwater. Next one. So we created a DM for the whole area. Next one. And then we did mathematical modeling, and you can see how the plumes are going to migrate. So you can see those pits will join after 10 years and make a bigger plume, and they will migrate one towards the Faridabad, and this side is coming towards the South Delhi, that is the near Qutub Minar, you can see. So, and then we can see that how much time it can take to contaminate the whole aquifer, and then what kind of the measures we should take up to stop this kind of the plume migration. Yeah, next one. So this you can see how a snapshot after certain interval of time and how the contaminant migrates and what will be the plume there. Yeah. I think this is all. I wanted to show you some of the slides. Yeah, thank you.
Thank you. Okay, Mr. Dev Sinponia, Chief Marketing Officer, BioPetroclean. So your company focuses on water treatment solutions. How do you think market-driven solutions can help industries improve water use efficiency? And are there any innovative products that have had a positive impact on water conservation in your company?
Thank you, Noah, and hello to all the panel members. So I'll start with something that sort of ties up all the conversations I was hearing today. And I have a presentation, Noah, but I will not give it. so I'll avoid the presentation. Yeah. So Laura was speaking about reuse in Panipat refinery. I have a very interesting user case there. We introduced automation and digitization in the wastewater treatment plants of Panipat refinery, specifically because they were generating about 20 million liters per day of wastewater, out of which they could only recycle half. They had an in-house UFRO and demineralization plant, but they could not meet the inlet quality to this plant. So we added the Industry 4.0 background to the Panipat refinery. That improved their capability of reusing wastewater within their existing infrastructure without adding new investments. We did it as a build, own and operate site. We're still operating it. And there is about 5 million liters per day of capacity, which can be taken up by Panipat refinery of that sewage that you're speaking about. Even if you give them untreated sewage, I think economically it will make sense to take it up and reuse it. So that's how the industry is tying up, and these are actual real life use cases. Now there was also a discussion by both Mr. Sharma and Professor Kashyap of Keshari of zero liquid discharge. Now sustainability is a round thing. It's not a one-way street, it's a two-way street. Right now in Tirupur, in the textile CETPs, if you open Google Earth or Google Maps and just look at any CETP, there are over 30 of them, I think, in that region, you will see mounds and mounds of salt. There is no place for this salt to be disposed. So before we do a blanket implementation of zero liquid discharge across India, we should first work on what do we do with this salt. Right now, it is very interesting, the solution they are coming up with is to mix that salt in water and dispose it in the ocean. So eventually that salt is going back into the water after zero liquid discharge apparently was done to have no wastewater discharge. So that's zero liquid discharge. However, with zero liquid discharge, there is a very interesting dynamics that comes into place, which is that now the only question is cost, because there is nowhere for the water to go. There is, and you cannot dispose such large amounts of water in the night. Everybody would know about it. It's very difficult. People have tried and they've been caught in India. So they're only left with optimizing technologies, introducing optimization technologies to take care of this water. And from our industrial background, our own technologies and the technologies that are coming into the market, it's very clear that now adoption of advanced technologies is making sense to the industries where zero liquid discharge is a regulatory standard. For example, we were able to see at a pharmaceutical site, I cannot take its name because there is some information that goes with this, we were able to reduce about 38% of their operational cost of achieving zero liquid discharge just by doing closed loop automation and data analytics. So we found they were dosing about 60% higher amount of chemicals than was required, and they had about 20% higher steam consumption than was required. So that really could be optimized. And I'm happy to say, especially with the zero liquid discharge, I don't know what to do with the salt, unfortunately, but at least regulatory-wise, this is creating a change in the industrial landscape. And now technologies are coming up to optimize it further. But I do see a very big, as I said, a very big opportunity for industry now to develop technology specifically to handle the salt content. That is the sort of the last boogeyman that is left in this circular design. Now, I think that being said, Noah, it's in India, we have seen a very interesting phenomena. Indian companies are actually, because we are a small Israeli company that has gone across the world. What we have seen is that in India, organizations have been more accepting of new technologies and faster to implement it. There has been a less pushback than, let's say, in Europe or in US or in the developed world. What we have seen is that Indian organizations are much more open and much more quick in implementation of new technologies. I think if anyone ever gets a chance, our project in Panipat Refinery would be such an example.
Just for the information of users, when we were talking about the satellite image maps used, for information of each one of us, those who know or even don't know, to remind them that ISRO, NRSA has prepared hydrogeomorphological maps on large scale using high resolution satellite imagery. And these maps have been given to all the state governments. And we found that people are not able to make application and utility of these things. Then the Ministry of Drinking Water Supply called upon India Water Foundation to train the Public Health Engineering Department people in the states. So we organized a training for 20 states and trained 40 people in each states to interpret and analyze those maps. And these maps contain a lot of information which is readable, interpreted. For example, the watershed can be delineated, micro and the macro. The watershed can help determine the drainage density of the watershed and drainage frequency of the watershed. Drainage density is directly proportional to the runoff and inversely proportional to the permeability. When we know all these things, then we can locate where to locate gabions, where to locate small check dams. So this has been, people have been trained because many people do not know the utility of drainage density and drainage frequency. Drainage density, as I told you, this sigma L upon A, sum total of the length of all streams, channels divided by the area of the catchment. And drainage frequency is the number of the streams per unit area of the catchment. When you multiply drainage density with drainage frequency, you generate a single digit number, infiltration number. Greater the infiltration number, greater the permeability. So utility must be known to the people when you have a map with you. When my professor, my colleague told about the maps, it reminded me of that the India Water Foundation had the opportunity to train 40 people in each PhD department of the states for interpretation analysis. And we started receiving certain further questionnaires and they have been answered again. Thank you. This was just the information of the knowledge of the people.
Okay, thank you all. Now we go back to you, Mr. Singh. So, given your experience in both the textile and water sectors, what are the key challenges and opportunities for improving water use in industries, especially in water-intensive ones?
I think my colleagues have covered most of the things. So I'll tell you a story. It's an evening time, people are looking for a cup of tea or something, and very heavy stuff also have come your way. So I'll tell you a story. I love telling stories. When I was in school, those days there used to be a very common, one question always used to come. The way she is asking question, in English it will say write an essay. And in Hindi it will say Nibandh likho. And generally you used to give certain topics. Sometimes you have a choice, sometimes you don't have a choice. So the most important topic those days used to be writing an essay on cow ya गाय पे लेख लिखना. So cows are not only important now, not in this regime. Cows used to be important that point of time also. तो हमने भी पूरा रट लिया था, Hindi, English both. Sorry, ladies may not follow my Hindi, but then So I have read the cow is a 4-footed animal and she gives calf every year and her cow is very, her milk is very sweet and blah blah and all. And it's lo and behold, I went there and the topic came, my favorite leader, and name of the leader was also there. Now I don't know what to do. So what I did is I substituted cow by the name of that leader and I say such and such X, I will not tell the name. X is a 4-footed animal and her milk is very sweet and she gives calf every year and all, and her calf is very useful. And naturally I got very poor marks. I went to the teacher, I said, sir, you told me that the question asked would be on the cow. He says, koi nahi. In English they did not ask about the cow, Hindi में गाय पे ही लेख लिखना आएगा. तो मैंने फिर गाय पे ही पढ़ा, गाय एक चौपाया जानवर होती है, उसका दूध बहुत मीठा होता है, बछड़े देती है, blah blah and all. And when I went to see when I sit in the exam, वहाँ पे आ गया फुटबॉल का मैच. अब व्हाट डू आई डू? तो मैंने लिखा मैं फुटबॉल का मैच देखने गया था, बहुत जोर की बारिश हुई, फुटबॉल का मैच रद्द हो गया वहाँ मैदान पे गाय घास चर रही थी, एंड देयर आफ्टर वॉट एवर मुझे मेरा गाय पे जो भी था मैंने लिख दिया. So this is what happens in most of the seminar workshops also, that no matter whatever questions he asked, you tell something which you feel very comfortable with, and you must have seen that also. So I will do the same. Whatever she has asked me, I'll forget for a time being, and for a few minutes which is given to me. See, I'm not again in the morning I said that I also studied engineering, and those days from a prestigious institute like IIT Kanpur. But then in 37.5 years in IAS, I have forgotten all my engineering. So I don't bring those PowerPoint presentations because, pardon me, but sometimes the PowerPoint neither have power nor any point in it. So I don't show any PowerPoint, nor do I have all those very good graphs and all which said. Some of them I could understand, some of them I couldn't understand. That's maybe true for you also. Having said that, I'll say some basic things. I always say, I don't go so much into the very nitty-gritty of technologies and this, that, or not. Some basic things I always try to tell. The reason being, when I came, joined Ministry of Water Resources way back in 2016, everybody was talking of how, whenever you talk of water, people will talk of only water scarcity. वैसे तो हम पहले और कुछ पढ़ते थे, जल ही जीवन है, रहीमन पानी राखिए, बिन पानी सब सून, पानी गए न उबरे, मोती मानुष चून. स्कूल में हमें ये पढ़ाया जाता था. Later on everybody says water is the elixir of life. जल ही जीवन है. Without water you can't even think of any living being on this earth. But today when you talk of water, nobody talks of water as elixir of life. People say water, water scarcity. So when I came here, I also used to do the same thing. I also used to show the presentations showing that how India's per capita water availability has been going down. It is 1/5 almost of what it used to be in 1947. Very late in the day, I realized what is the significance of per capita water availability when 90% of your water goes into agriculture. So why should we talk about the... Similarly, I used to ask one question in the morning also be said. I asked, what is the what is the average rainfall India gets? How many of you think, how much rainfall India gets per year on an average? Anyone? Chalo, theek hai. 1,000, 1,100, 1,200, whatever, say more than 1,000 millimeter rainfall. Fine, I do agree that its distribution over time and space is very weird. Most of the rainfall we used to get, now a slightly change is there during the monsoon season. We also know that we have one of the wettest place on the earth, we have only one of the driest place on the earth. But the fact remains that we get more than 1,000 millimeter of rainfall. The lady who is sitting there, Israel is today known for different regions, but we know basically Israel, as someone who has worked in water sector for long, basically for a different region. You know how much rainfall Israel gets in a year? Any idea? Is less than 500 millimeter. So they get less than 50% of the rainfall which we get. Yeah, no, that's also, in fact, people asked me once I was talking about this, people say, why are you comparing India with Israel? They are not the similar country. Yes, the scale is not the same, but they also have the same two problems. They also have certain areas where very good rainfall is there. There are certain areas, 60% of them has less than 100 millimeter rainfall, he says. Similarly, they also have a particular few months which are completely dry and only few months rainfall is there. Then why is it that in India we keep talking of water scarcity and we don't talk of water scarcity in Israel? And answer is just simple. The simple answer is management, water management. So crux is not basically so much of a water availability in a country like India, but it's basically a water management. And when you talk of water management, in the morning I was telling, we always used to talk of supply side management. How to increase the availability of water. I'm not saying that's important, but it is time when we talk of a demand side management. Very simple to understand. When you say supply side management, it's like increasing my own income. But I can't increase my income beyond a point. The other is basically reducing your expenditure, which is a demand side management. So it's a supply side management and demand side management. Now, industry is important. I'll come to that slightly later. But I always say that a water sector reforms cannot be done unless we reform the water use in agriculture sector. Agriculture is something which people do not want to talk to. It's a very kind of a sensitive kind of a thing. But the fact remains that 90% of water, almost 89-90% of water goes into agriculture. And what is the water use efficiency in agriculture sector? It is estimated to be 35 to 40%. That means we are using 2.5 times to 3 times more water in agriculture than it should be used. I remember I used to go about the groundwater guidelines as a Secretary of Water Resources. I had to attend before the NGT chairman. And NGT chairman used to say, we will stop all industries in such and such area, no industry should come. I said, how can in a country like India, a developing country, we should think in terms of stopping an industry where even if, because industry consumes about what, 5% of total water or something. So even if we save 10% of that 90% which goes there, we'll get something like 9%, which will be good enough for the industry to feed. So that's what I'm saying. Nobody talks of water use efficiency. Whatever I'm not talking of, there could be structural measures, there could be non-structural measures, there could be crops. In the morning I was saying, we don't grow crops as per the agroclimatic conditions of the area. We grow paddy where rainfall is 500 or 600 millimeter rainfall in Punjab and Haryana, where it shouldn't be grown. We grow sugarcane maximum in Maharashtra, and Maharashtra is known for water scarcity. Vidarbha region and all those regions we know. Not only that, agronomic practices. Everybody talks of paddy as a water guzzler. I tell you, paddy is not a water guzzler crop. It's a water tolerant crop. It tolerates water. If you have a maize and the standing water is there for 1 day, the maize will wither away. The paddy would not. बट इसका मतलब तो ये नहीं ना कि जैसे हमें प्यास लगी हो 2 ग्लास की, अब मुझे कोई 6 ग्लास पानी पिला दे तो क्या होगा, मैं तो उल्टी करूंगा. तो we make our crops vomit actually. One of the reasons why our crop productivity is less कि हम इतना पानी देते हैं जितनी पानी की जरूरत नहीं है. I remember Honorable Prime Minister was inaugurating something called Atal Jal Yojana, Atal Bhujal Yojana, Atal Jal Yojana in Vigyan Bhavan, and उन्होंने एक ही चीज पूछा कि भाई पानी जो है वो पौधे को देने की, हम कहते खेत पटा के आ रहे हैं, आप पौधों को पानी नहीं देते हैं इंडिया में, हम खेत को पानी देते हैं. He gave an example. He says कि अगर बच्चा आपको दूध की जरूरत है तो आप बच्चे को आप किसी ग्लास से या किसी चीज से चम्मच से बच्चे को पानी दूध पिलाएंगे या दूध से उसको नहला देंगे. तो similarly what we do. So whether it's an agriculture, of course, the same is true for industry as well as our personal consumptions. You know how much an average in a city where a groundwater supply is there, I think a per person consumption of water is something like 120 liters or so. And in some areas in Delhi, I have stayed for 13 years in something called a New Moti Bagh in heart of Delhi. And the average consumption per person per day is something like 500 to 600 liters. Do we really need that kind of a water? Similarly is the case with the industry. Of course, for industry, it's a question of survival also. So perhaps they have to take a little more seriously. But then I don't know how many industries, of course, industries have started working, as you were saying, quite a few industries. But there is a scope in industry for both. There is a scope for supply side management. I don't know whether even in Delhi, every time, I shouldn't get into politics, but maybe you find the Delhi Chief Minister will coming out, go to the High Court, file case against Haryana government or something that they are not giving us enough water. Is it that every household, even every government building in Delhi has a functional rainwater harvesting over it? No. So what the basic things which we need to do? So similarly is the case with the industry. They are an industry with a huge area actually. I was once joint secretary in the Ministry of Steel, and I have gone to the steel plants and the kind of area and the kind of townships they have. And similarly is the case for demand side management also. Some of them all of you said. But I don't know. Unfortunately, Archana Verma is not there. When I used to be secretary, I tried to push in something called a National Board of Water Use Efficiency on the lines of what is called a Bureau of Energy Efficiency. Of course, 1 in the morning, somebody says that you pay for, in most of the cases, you pay for electricity, you don't pay for water. In many cases, of course, industry do pay. But right now, for example, I remember there used to be a scheme called PAT, Perform, Achieve and Trade, whereby certain designated consumers, for them a norm was fixed. And they were supposed to achieve that norm over a period of 3 years or whatever. If you are not able to, there was a concept of energy certificates actually. And those energy certificates could be traded. So I'm saying, why can't we have some kind of a norms, especially for those industries who use more water, including, let's say, a textile or power or whatever, so that we have a norm and everybody has to, and if they don't, there should be a concept of water certificates, and that water certificate also should be kind of traded. In the morning, I was talking of water footprints. Now, carbon footprints, today there is a carbon trading. Why can't we have some kind of water footprints and even water credit markets? There has to be, because everybody talk of, which I also talked in the morning of 5 hours. But 3 hours, everybody talked of reduce, recycle, reuse. Of course, even for a recycle, reuse, there has to be both. There has to be certain amount of mandating and there has to be certain amount of incentivizing. I think the both have to be there. Having said, finally, I coming to see was saying about the textile. In fact, I am also associated with one of the, like a GIZ. There is a company from Netherlands called Solidaridad. And everybody was talking of Panipat. So from National Mission for Clean Ganga, a project has been sanctioned to Solidaridad. And I'm also advising them. And simple, the task is that how do you cut down water consumption by 30% and chemical consumption by 25%. And for whatever units they have taken, it has been easily have been able to do it, and not very big interventions. The small interventions in terms of better processes and in terms of better technology. And sometimes technologies are not very rocket science technology. For example, somewhere the water is not being measured. All you do is just put something which measures, or maybe automatic cutoff. As we see in our houses or somewhere on water head tank, if the lots of time we see the water flowing actually. So if you have water cutoff, so this small technology has been able to bring something like a 30% or 40% reduction actually. So there is a scope. I'm saying in industry also, there is a scope for both demand side management as well as supply side management. And the role of government basically should be to kind of facilitate, in the sense certain policy changes must be brought in, which will kind of mandate the industries as well as incentivize the industry to be more efficient. Thank you very much.
Thank you. By the way, if we're talking about efficiency in agriculture, there is a very interesting work of Israeli companies for drip irrigation in India. They had the research about paddy, drip irrigation in paddy, and they found that they can use 70% less water with 30% more crop for paddy. So it's very interesting, and I think it should be implemented. So thank you, esteemed panelists. It was a very interesting discussion. Thank you for listening. You have a question, of course.
I can hear, yeah.
The need of the hour is the water harvesting. That solves most of the problem. Not only that we make use of the water that is coming from yours, it's an asset of the purified water to give. Store it in the ground water. Now to solve our problem of flooding. As a matter of fact, there has been separate session on water harvesting alone. I hope you have got my point.
I completely agree with you. Problem is that in the mornings, again, the time was not there, but I always say, I'm not someone who is saying that dams have not served their purpose. Dams have their purpose. I'm not saying damn the dams also. But the fact remains that going forward, it would be almost impossible to construct any big dam in India. There is no need. My point is that we have to have a paradigm shift from big to small. Why can't every let us say field should have a farm pond? In the morning I said that slogan, now it has become very common, but I always said the Catch the Rain campaign. What do we say? Catch the rain where it falls, when it falls. आप जहाँ पे कहते हैं ना कि भाई जहाँ पे पानी पड़े वहीं पानी को रोक लो. I remember when I used to be Secretary of Water Resources, I was in additional charge of Secretary Drinking Water and Sanitation. ये जल जीवन मिशन में था कि हर घर नल का जल. Initially, I was not very keen on nal ka jal also because sometimes it leads to a lot of waste and all. But anyway, this is a government program. I always used to say that source sustainability is very important because tomorrow you will have a tap, but no water will come from the tap. So it's very easy. You have a good contractor, you will lay down everything, intake well, pipelines, everything. But wo pani aayega kahan se? So there was a program that every school should have first a tap water. I said no. I will ensure that, but every school building should have a rain water harvesting also. दो पर्पस के लिए, एक तो रेन वाटर मतलब रिचार्ज होगा, ग्राउंड वाटर रिचार्ज होगा, दैट्स अ डिफरेंट थिंग. बट देन एवरी स्टूडेंट में कुछ तो पूछेगा ये क्या हो रहा है, छत पे ये क्या बन रहा है, पानी को नीचे डालने से कहाँ जाएगा पानी. तो बच्चे को समझाएगा कि भाई देयर इज समथिंग कॉल्ड अ कंसेप्ट ऑफ एक्यूफर. इन द मॉर्निंग आई सेड व्हेन आई वाज अ डिस्ट्रिक्ट मैजिस्ट्रेट in a district which is drought prone, I never knew what is an aquifer. I never knew what is a groundwater. Whether groundwater is going up, groundwater is going down. Whether a proper crop is being grown or not. So we didn't know any such thing actually. So as you rightly said, the need of the hour is basically some kind of what you talk about the water conservation, large number of small structures. In the beginning, I discussed about the urban flooding. One of the major reasons is that we have destroyed all our water bodies in urban areas. So thank you. That's right. It was a suggestion, not a question.
In fact, it requires a sustained campaign. It should go into the head of the chief ministers. Only then the things will improve.
Okay, thank you very much.
And sir, one more point. Haryana is in, so far as water resources is concerned, is in ICU. Because it is all because that we don't have dams across river Yamuna. No, nothing.
Thank you. Thank you, Mr. Chairperson. Thank you, moderator. Thank you, esteemed speakers. To do the honors, may I invite on stage Dr. Shweta Tyagi from India Water Foundation to kindly present mementos for this session as a token of our appreciation and thanks. We thank Mr. Devendra Singh Fonia, Chief Marketing Officer, BP Clean. Our thanks to Ms. Laura Sestersik. And our sincere thanks to Professor Dr. A.K. Kesari, Department of Civil Engineering, IIT Delhi. That's why we're not presenting it to you. Thank you. May I request you all to please join us front and center for a photo op.